So today what is the question is to find the frequency of every element in that array. So here we have given an array of positive integers. These elements will be like from range from 1 to n, where n is the size of the array, and some of the elements might be repeated, so that and then some also will be absent. So what we need to find is, for every element we have to find that frequency for every frequency from 1 to n. That is, when we take this example, um, the input array is 2 3 2 3 5. So here we are using the one indexed array, so we don't have any 1, so 1 will be zeros. So 2 will be occurring 2 times, 3 will be occurring 2 times, and then 4 is not occurring, so 0, and then 5 is occurring 1 time, so it's 1. So what's the brute force means? We can use hash map or a frequency array to store the frequency of every element. I'll just code that now. So so we have to get the array right. Scalar is equal to start.get equal to 0. So we have to get the input array. So I'll run it as input array. So what we can do, okay, I'll do here itself. We can store here itself while getting the input, but it won't be good that much. So for every element we have to store its frequency. So here we are using one index, so we have to do 1 minus 1. So in Java, basically every element will be 0 initially, so this array will be initially 0. So for every element, when like for what 1 comes means, yeah, it has to be stored incremented in the 0th index. So I am just using flick of r of minus 1 plus plus, so incrementing will increment the count, so we can print the count. So I'll compile. So this is the expected output. Here we are getting the same output. So I will code that efficient. Not a brute force approach. This is a better approach. A brute force approach can be looping through every element using big O of n square, which is not good. We can use this better approach. But the thing is we are using a space of big O of n. We can implement this program without using it because the numbers will be from 1 to n. We can use this array itself because I'll explain that. So here we don't need the code. So basically the array is 2, 3, 2, 3, 5. So what we can do means we can use the variable like to I'll just say it in a simple way. So we just need to go to that respective index and then add our length variable. So here we have the length 5. So I'll just have a variable like k equal to length plus 1. So here k equal to 6. So what means for every element we travels while traversing we have to get the mod of it. I'll just try run. Better I'll code now. I'll explain that later. So int k equal to n plus 1. For n equal to 0 less than 1 and plus plus int x equal to r naught and k r naught minus 1 is equal to k r minus 1. We'll just print it up. So now I'm getting yeah, we have to do mod here. I'll make k 5, 2, 3, 2, 3. So this is the expected output. So let us see how it works. So what I'm doing is just declaring a variable of k which is n plus 1. So what will do means I have to find that respective index where it is like it has to go. Here we take 2 means it has to be added here, right? So what I will do means I am just doing the mod of k. Why I am doing k equal to n plus 1 means I will explain that later. So here k is 6, right? So 2 2 2 mod 6 will be 2. So here we are using one index, right? So it should be stored in a previous index. 2 means here it has to be stored in one index. So and then the respective element should be incremented by the kth value. I will also explain that. So what happens here? 2, 3, 2, 3, 5. So 2 will come. 2 mod 6 will be 2. So this will go to this one index and then it will be added by 6. So this will become by 9. So then here this element will come. So here the actual element is 3, right? But using this mod you can get that appropriate element. So you can see 9 mod 6 will be 3, right? So we get the we got the approximate element. So this 3 has to be incremented by the previous location, so it has to be incremented here by k, so it will be 8. So this 8 will be now mod again by 6, so we get 2. So using this mod will retrieve the current appropriate element even after adding k. We are just adding k means, so after doing division and then the remainder will be the correct element. So here we again go to, it will go to 2, so this will be 15 as we saw in the output. So 3 comes again, 3 mod 2, so sorry, 3 mod 6 will be 3, so it will go to this index, that is second index. Here 8 will be incremented to 14, so 5, so 5 will be mod by 6. So here if I used 5 mod 5 means we can use n also, the length of the array. So here the thing is, it is one index, so if we were using 5 mod 5 means it will be 0, so 0 minus 1 will go out of bound, so it will lead an error. And then another problem is when we do 5 mod 5, we can do what I did means, if index are double equal to 0 means, then go to the last index, but here it is already 5, so if we add, that means it will become 10. So so after in this output we getting the frequency by dividing by k, so if you divide by 10 divided by 5 means it will give output as 2, so I received the wrong output, so we should not do that, so I am just doing n plus 1. So here 5 mod, using 5 mod 6 will give the output as give the index xy, so we'll do minus 1, that has to be stored in 4. So here the 5 will be incremented by 6, so it will become 11. So this is the final array. This is 2, 15, 14, 11, sorry, 2, 15, 14, 3 and 11. So we are adding by k, right? For every element we are adding by k. So after dividing by k, we will retrieve the frequency. So basically what it is means, what the element will be is, the r of 5 will be r of 5 plus the frequency of r and then into k. So to get the frequency we can divide by k, that element, so we can get that. Okay, so this is here if we divide 2 by 6 means 2 by 6 is 0, it will be 0. So 15 by 6 is 2, so it is 2. So 14 by 6 is 2, it is 2. So 3 by 6 is 0, it's 0. So 11 by 6 is 1, so it's output. So this is the final optimal solution. So I'll just run it here. So here we have to use the integer to return. Just copy paste and we move to return. So here the output comes, expected output is good. So yeah, it's passing the all test cases, and it is one of the best approach and optimal most optimal approach here. Thank you.